For this activity, you can see that each of the cards, this is looking at, we're going to fill in page 107 and 108 of your book. But if you were to print out these handouts, which I posted online, they're cards where it has a question in the center, and then there's an answer, but this answer doesn't correspond with that question. It's the answer to one of the other cards. So if you want to try this out, you should first. The big idea is knowing that if you have the square root of some number equal to some other number, that we can do the squaring to both sides to undo the radical. So that would get us x equals a squared. So basically you could square both sides. So knowing that, you could go ahead and try some of these and then check back. So now that you've tried some of them, looking at this first equation, I'm going to undo that radical, so I'm going to square, but again, maintaining balance, square both sides. That means x minus 6 equals 25. It's a regular linear equation. Add 6, we get x is equal to 31. Now, one thing that you do want to check for is extraneous solution, so make sure that these don't make anything bad happen. So what I mean is the square root of 31 minus 6, just make sure it works. That's 25, which equals 5, yay. Because sometimes when we're working with radicals, which have a restricted domain, some weird things kind of happen sometimes. All right, let's look at the number 31. Now before you can square, because that's what we'll want to do to undo that radical, we need to move over anything else. So we need to still isolate, just like we isolated the absolute value and isolated the things that were squared. We want to isolate the radical. So this is going to be the square root of 2x plus 4 equals x minus 2. We're going to square both sides now, so that way the left side becomes just 2x plus 4. Now be careful on the right, because if you're squaring a binomial, that means x minus 2 times x minus 2, which if you distribute, that becomes x squared minus 2x plus 4 equals 2x plus 4. We combine our like terms, 2x plus 4 equals, we have x squared minus 4x plus 4. So now we're back to a quadratic equation. I know it's quadratic because I see a power 2. So I want to make this equal to 0 since I have x's and x squares involved. So I'm going to move the 2x over and move the 4 over, minus 2x minus 4. That gets me 0 equals x squared minus 6x. Oh, and those cancel too. So when I look at this and I want to think about factoring, I only have two terms and they both have x, so I could pull that out, x minus 6. So since we have this equal to 0, that means either x is 0 or x minus 6 is 0. So if I add 6 to both, I'm going to get x equals 6. So it looks like I have 0 and 6. Before I box those up though, I'm going to check that it's okay. So if x equals 0, I'm going to plug that in. 2 times 0 plus 4 plus 2, this is supposed to equal 0. Well, this is going to be the square root of 4 plus 2, that's 2 plus 2, that doesn't equal 0 though. So then that means that this cannot be the answer. It was a solution to our quadratic, but it doesn't answer our original radical equation. So let's try the 6. Let's see, that's square root of 2 times 6 plus 4 plus 2 is supposed to equal 6. Well, this is 12 plus 4, that's square root of 16, plus 2 is supposed to equal 6. 4 plus 2 does equal 6, that one checks. So that's my answer. And again, this one we call extraneous. It's like the extra one, the guy that doesn't work. All right, and you can see these are actually in order here, so it has the answer that we just saw. So let's again isolate the radical. Minus the 50, we get the square root of 9m equals negative 9. We're going to square both sides, square, we're going to get 9m equals 81, divide by 9, we get m equals 9. So I want to check that this is okay. And I'm going to have the square root of 9 times 9 plus the 50. Well, this is the square root of 81 plus the 50. That's 9 plus 50. That's not going to equal my answer. And I actually noticed the problem a little earlier, right here before I squared. I had the square root of a number equal to something negative. That can never happen. if you think about the graph of our radicals, our square roots anyway, they always had a domain of all numbers bigger than 0. They never went into the negatives, so this statement right away I know doesn't make sense. Well, if you did the work, not noticing that, when we check, we can see that it doesn't work. And so that means that 9 can't be a solution. So in this case, we actually have no solution. That 9 is extraneous. Okay, moving over to the next guy, we have x to the third plus 27 to the 1/3 equals x plus 3. Well, it doesn't appear that there's radicals at first, but then remember that 1/3 was just a different way of writing a radical. It means we have the third root of x to the third plus 27, and that's equal to x plus 3. Now we've been squaring these different quantities. This one, in order to isolate well, it's already isolated, but if we want to get that inside part, we have to cube to undo the cube root. So that's x to the third plus 27. Now over here, x plus 3 cubed is x plus 3 times x plus 3 times x plus 3. That's going to take a little bit of work, but the first part here, distribute, will end up being x squared plus, we'll get a 3x plus another 3x plus 9, and then we'll have to distribute that. Well, this is actually x squared plus 6x plus 9 times the x plus 3. And so if we distribute that, I'm going to just distribute this way instead. We're going to get x to the third plus 6x squared plus 9x. Then do the same thing with the 3. That's going to be plus, we'll get a 3x squared plus 18x plus 27. And over here we have x cubed plus 27. I could combine some of my like terms here. Let's see, what do I have? 6x squared can go with 3x squared, so I'm going to have x to the third plus, that'll be a 9x squared. 9x and 18x is 27x plus 27. This is x cubed plus 27. So then we can subtract the x to the third, that cancels those out. We can subtract 27, that cancels those guys out. And so all we have left is 0 equals 9x squared plus 27x. Again, we don't have that third term, so we can just look at this as having the GCF of 9. 9x times x plus 3 equal to 0. So that means either 9x is 0, which tells me if I divide by 9 that x is 0, or x plus 3 is 0. So if I minus 3, that gets us that x equals -3. And again, I want to check. Now x cubed doesn't have as many restrictions and cube roots because they have all domain, or all real numbers being the domain and the range. And so there shouldn't be any problem, but you should just double check both of those that they're okay, and they should work. All right, this next one, we have 2 radicals. Well, that's okay. What we'll want to do is just square both sides, because look what happens. If we square the left side and square the whole right side, it will undo that radical. So we'll have 3x plus 21. On the right side, we gotta be a little careful, because we have 3 square root of x minus 5 times 3 square root of x minus 5. So the square root of x minus 5, square root of x minus 5, we know that that will undo the radical. But we also need to do the 3 times the 3, which is 9. So we're going to have 9 sitting out there. So if we simplify that, that'll be 3x plus 21 equals 9x minus the 45. Let's see, we can move the x's to be on one side. This is a linear equation. And we're just going to keep solving like normal. Add the 45 over, add the 45. This is going to be 66 equals 6x. Divide by 6, we get 11 is equal to x. And then we can, again, check that. Got a lot of radicals going on. Makes me want to check it for sure. Square root of 3 times 11 plus 21. This is supposed to equal, we hope, square root 11 minus 5. So this is 33 plus 21, which is 54. So square root of 54. And over here we have 3 square root of 6. Now it doesn't look exactly equal, but if we simplify the radical here, that's 9 and 6. 9 can come out because that's 3 and 3. So we'll get 3 square root of 6 equals 3 square root of 6. Checks. So x equals 11 is my answer on that one. All right, we got one more. Now this one looks a little bit different. It still has two radicals like the last one. But if I try and move one of these guys over, move the square root of 9x over, we have the square roots on both sides like the last problem, but this time we have 8 minus radical 9x. And so when we square both sides, we're going to eliminate the radical on the left, but the right side actually looks a little crazy. We're going to multiply this out twice, and we're going to have to distribute that. So that's different from the problem we had a second ago where everything was multiplication there. Here, we have these terms being added, so we have to be a little careful. So if we distribute that, we're going to get 8 times 8 is 64. 8 times that radical is negative 8, radical 9x. Do it again, we're going to get another one. Negative 8, radical 9x. And the last two is going to turn to plus, and that's a radical times a radical. That will end up being just 9x. It cancels out. So I have 9x plus 16 equals 64. These are like radicals, so it'll be minus 16 square roots of 9x plus 9x. So we still have a radical going on. So in this type of problem, we're going to have to actually square things twice. So we already eliminated one radical by squaring. We're going to have to isolate this radical. So I'm going to minus the 9x and minus the 64, minus 9x minus the 64. So that actually cancels those x's and those x's. 16 minus 64 ends up being negative 48. So I have negative 48 equals those canceled, negative 16 square root of 9x. Now before I square, I can actually divide by negative 16, and so I get 3 equals the square root of 9x. And so if I square to again get rid of that radical, I get 9 equals 9x. If I divide both sides by 9, I get x is equal to 1. And you can check that, make sure that it does work.